And this is how you test an LED panel. In the previous video, I have repaired an LED television that has a backlight failure problem, which I fixed by replacing a diode in the LED backlight driver circuit. But this problem can actually caused by either the LED backlight itself or the driver circuit. The easiest way to isolate the problem is to use an LED backlight tester device, which can be bought online for a few bucks. But in this video, I will show you how you can make your own LED backlight tester using only a common electronic parts. The difference is that most off-the-shelf version has an integrated voltmeter, but my DIY version will use a multimeter for a voltage reading. Otherwise, the operation is about the same. This circuit can test everything from a long string of LEDs with a voltage rating of 100 or 200 volt, down to about a single LED chip without any problem or damaging to the LED chip. Let's start with a circuit diagram to better understanding how this circuit works. This circuit is basically a high voltage, current limited, isolated DC power supply. On the input, we feed the main voltage through an isolated transformer consists of two 12-volt AC transformers connected back to back. Then we rectify it to a DC voltage of about 300 volts with a bridge rectifier. Then use a 20 kilo ohm resistor to limit the maximum current to about 15 milliamps, which is a safe current for an LED. Then I measure the voltage across the LED module with a multimeter. Because this circuit runs at a main potential, the isolation transformer part of the circuit are essential for a safe operation. For this project, you will need two of the 220 volt to 12 volt 300 milliamps or more AC transformer. If your main voltage is not 220 volt, then just replace the input transformer with the one matching your main voltage. An RB40 bridge rectifier diode or any bridge rectifier with a voltage rating of more than 300 volt. A 20 kilo ohm 2 watt resistor. A quarter watt resistor would also work but will overheat on a continuous use. A DC voltmeter or a multimeter set to a DC voltage range. You will also need an AC power cord and a pair of Alligator Clip cable for a connection to the multimeter. Start by connecting the AC power cord to the 220 volt side of the input transformer. Then connect the 12 volt side of both transformers together. And now you got a simple isolation transformer that can be used to repair a switch mode power supply safely. For testing an LED tool, we just need to add a bridge rectifier and a resistor. Now it's time for testing, but today I don't have an LED TV on hand, so I will be testing a ceiling light LED panel instead, since the internal circuit is quite similar. First, you should set the multimeter to a DC voltage range or a 600 volt DC range before plugging in the power cord. The meter will show the initial high voltage reading of about 200 to 300 volt. When testing a real LED TV backlight, you should always disconnect the cable from the PCBs to prevent damage to the driver circuit. Then connect the positive and the negative probe to the LED panel, and the entire LED string will light up, so you can identify the broken LED chip easily. On the meter is the volt forward of the current LED string. The current string measures about 60 volts, which are about the same as the LED TV I have tested before. Let's try on a longer LED series like this one. You can see that this string has a higher forward voltage of about 116 volts, which depends on a series parallel circuit topologies. In case the LED panel circuit is broken up, you can also test each part of the string independently to find the culprits. This circuit can test from a single LED up to about 200 volt LED module. Now, what does the broken LED panel look like? In this panel, there is a broken LED chip. Let's see if we can identify it. You can see that some of the LED chips didn't light up, while the others are light up properly. The meter reading also seems reasonable for this panel. In a series connected LED panel, this is a short circuit LED chip. Sometimes you may have to step through each LED pin to identify the broken chip. And this is a small LED panel. This circuit can test from a single LED chip without a problem or damaging to the LED chip. Okay, that's it for today. If you like this video, please consider hit the like button, share and subscribe. Thanks for watching. See you later. Goodbye.